and welcome to the next part of our video series. This is going to be a video on skimmers for permanent use, where we're going to go through a couple of case studies and talk about why you may want to consider a skimmer for permanent use. Skimmers traditionally have been considered temporary use only, as when they first came out, most of the products were PVC and probably not ideal to use permanently because of issues with PVC. But now that there's other options out there, we want to talk about why you might want to consider that. So getting this started. We've done two videos already, or two in the series. First one was about just basic skimmer basin design based on volume, and went over the Rymar Marley Float selection tool on that. The last one was on advanced sediment basin design using SEDCAD, which is a sedimentology modeling software. Again, this one's going to be skimmers for permanent use. We're going to go through a couple of case studies, just talk generally about why you would want to do that, basically information only. In the future, we're going to talk about advanced skimmer modeling and hydroflow. If you did decide you wanted to use it permanently, how would you put that into your hydrology model? And then we're going to wrap up the series, at least for now, talking about volume-based versus filtration-based water quality. And then we're going to do some water quality modeling and talk about volume-based modeling, how that's typically done versus filtration-based modeling, and provide a design guide for how you would do that. So typical dry detention basins. Now, obviously, there's dry and wet basins out there. They both function similar. Obviously, wet basins have a permanent pool, but a typical dry detention basin has an inlet, as the low flow orifice located at the bottom of the pond, and that's where sediment is going to accumulate. Typically you will have, once you finish construction, you're going to remove the skimmer. You're going to put in a low flow orifice installed at the bottom of the riser, typically that size to release the first flush or water quality volume. Possibly your low storm, like a 2-year storm event as well. And then depending on the size of that, for smaller sites especially, those low flow orifices can get really small, less than 3 inches. And so you're often going to include some sort of guard or filter to try to reduce the clogging. But that is going to need significant maintenance because, again, the idea with detention ponds is to allow time for sediment to settle, i.e. get to the bottom of the pond. And so then they're going to get right to where we're trying to let the water out. So as said, for water quality, typically for typical basins, they are going to rely upon the natural settling of sediment particles as they travel from the inlet to the outlet. So your inflow here, you're going to come down and reach to your outlet structure. The skimmer, if you use that, is going to release the cleaner water from the surface. They've been widely accepted for construction. They've proven to be very cost effective. They make sense to use during construction. So why wouldn't it make sense to use for post-construction? Like I mentioned previously, when skimmers first came out, majority of them were PVC. And so PVC has UV issues and just generally is not good for outdoor long-term use. And so now that there are other options, they can be considered for post-construction use. So first case study here, this is a pond. Actually, yes, all this green vegetation is a pond. It was a former Chevrolet site in Simpsonville, South Carolina. Not surprisingly, in 2013, they received a notice of violation for failure to maintain the pond. Probably was long overdue. Pond was obviously severely overgrown and the outlet structure was not functioning properly. So at the time we had a company that did pond maintenance. We worked with the owner. We cleaned up the pond, actually did some timber harvesting out of there. After the initial removal of the vegetation, it was determined that the pond had accumulated about 6 feet of mud and debris. There was a 2-inch outlet at the bottom of the basin outlet structure, and it obviously had been clogged for many, many years. The pond was about 3/4 to an acre in size. It had very steep banks, about 1.5 to 1 side slopes, and the volume of muck to be removed. Initial estimates for cleaning out the basin were somewhere in the $60,000 to $75,000 range. Again, this was about 10 years ago. So this is what the pond looked like after the vegetation, but it would rain You can see the orifices here in this picture that are, several feet above the bottom of the pond, but there was no low flow orifice. Again, that was clogged. This is what it looked like once the trees have been taken out. So we got most of the trees out of the pond, actually, cleaned up fairly well. And we redesigned the basin to allow the muck and debris to remain in the pond and modify the outlet structure, but still meet regulatory requirements. So this was in Greenville County, South Carolina, and the original 2-inch outlet for the low flow outlet, Greenville County wanted to maintain that flow rate. So they wanted to keep another 2-inch outlet in there, or we looked at an option of having to putting in a skimmer instead. So redesign of the pond resulted in savings of well over $50,000 for not having to build a road and haul this stuff out and find a place to take it. So we worked with the county, and they agreed to let us put in a skimmer with a 5-inch orifice, and we installed that as a pilot project. And that we showed that we modeled it to show the 5-inch orifice provided very similar flows to the previous 2-inch low flow orifice. And this was, pictures, not great pictures back then, but anyway, pictures when it was first put in. Here on the picture on the right, you can see where we closed in the previous orifices, put in new orifices here above, a little higher up. The pond had volume available, and then you got your outlet structure. Hard to tell in this picture, but those are 6-foot riser sections. So this is showing 12 feet height of the riser. And again, we had additional 6 feet below grade that was this muck sediment accumulating. You can see the dark organic sediment that accumulated and been put in there. We modified the other orifices to control the larger storm events. So as a pilot project, the county required us to monitor this site monthly for the first year to make sure it's working properly, which we did. So you can see these pictures here, Skimmer's doing its job, draining the pond down, working pretty well during that first year. So in August of 2014, the owner was doing some maintenance. It was time to cut the pond again. Again, these very steep side slopes, so they had cut all the sides, just allowed the debris to go down the bottom. They were going to just then, put it all together and haul it out. Before they could do that, they had about a 5-inch rain, one of those major afternoon thunderstorms in August in South Carolina. In about 8 hours that filled the basin up entirely and washed all that gunk and debris down to the outlet structure. Despite the large amount of debris in the basin, the skimmer did not clog and the basin did drain out. And we've had the 2-inch outlet in there, you can imagine that it would probably have taken scuba gear to get down there and unclog it with that much debris in the basin. This was once they got it cleaned out, landscapers did their job, cleaned everything back out. Skimmer's, very functional again. So just kind of recap on for this site, the modification of the pond outlet structure to include a skimmer saved over $50,000 in just the pond maintenance expense of having to haul and dig out all the muck and debris. The skimmers function very well as a low flow water quality outlet. And the skimmer has been much less prone to clog and easy to access for maintenance. They got a rope on the skimmer, and occasionally they do have to kind of shake it off. Again, skimmers are not maintenance-free items. They do need some attention every now and then, but it's been there now for, let's see, over 10 years, or just right at 10 years, and over that time has functioned really well. So the second case study we're going to look at is a site in Charlotte, North Carolina. This was a similar site where in 2012, this property received a notice that it was going to be inspected for compliance, which was nice of the city to send out, hey, we're going to come check your pond out. And the owners, to be honest, they said, what pond? I don't think they knew they had a pond at the time. And they called us and said, hey, we got this notice and we don't know what they're talking about. Can you help us out? Well, this picture here shows all the trees and stuff growing. And you can see here, that's the concrete spillway. That was how we knew the basin was there. So we went down, checked it out. It had a head wall and a pipe going through the dam. That was the outlet structure. It was in a live stream, which is, kind of a no-no these days to build a dam across a live stream, but this had been there quite a while before the wetland regs kicked in. And it had a large spillway as part of the outlet as well. So Charlotte also has a very high stormwater utility fee. And the owners asked us while we were doing this if we could help them apply for stormwater credit to help offset the maintenance costs. So the initial work involved removing buildup of the mud and debris from the existing outlet. We reduced that outlet to a 6-inch outlet in order to obtain a 45% fee credit for the owners, and they were really pleased about that. The stormwater fee on this site was around $20,000 a year at the time, and so $10,000 a year savings was pretty substantial. Well, cleaning out the pond did not work that great. So it was a very natural area because it was a wetland. It couldn't be completely cleared of trees and debris. Every time it would rain, they get a large amount of debris that would go to the outlet. And a lot of times it would clog the outlet. And the outlet's probably 4 to 6 feet underwater. And so very difficult to get to and very slow to drain, for water to start going through the debris and stuff to get out. And so the owner said, "Hey, this is really not working. What can we do?" And so we said, "Hey, why don't we look at installing a skimmer? And that will help you, limit the clogging." We'd done the job in Simpsonville with a skimmer, but the city of Charlotte stormwater manual specifically did not allow skimmers for permanent use. And so we went and met with the city and let them know, hey, we've got this skimmer that is an HDPE product rather than a PVC product. It's very durable. It's UV resistant. It's designed to be part of the permanent outlet structure. Will you allow it? And City of Charlotte said, yeah, we'll allow that. So we redesigned the pond. We put in an outlet structure, a riser structure in the pond, and we put in the skimmer. Went through the calculations. In doing this, we also had a focus on trying to maximize their stormwater fee credit. In doing so, we got the credit up to a 95% fee credit. And initially, we got a note here, provide an HDPE pipe from the skimmer to the outlet. That'd be this section here. And I'll talk about that a little bit more as we go along. So city approved it, $25,000 a year savings in stormwater fees, clients thrilled. And so get the contractor to come in to put it in. So we've got our new outlet structure, got our pipe coming out, skimmer sitting there. You can see the rope they've tied to it so they can make sure they get to it. Cleaned out some of the accumulated sediment here to give a little sediment storage as well. The cost to put everything in was about $50,000 once they got everything done. So the stormwater fee credit paid for that in about 2 years and made it much easier to maintain, much less maintenance needed to keep the pond function properly. Had some minor issues kind of going through that, but it's functioned way better than the previous outlet. One of the issues was that the HDPE pipe actually bowed. Didn't think about that with HDPE. HDPE is pretty good UV, but when it gets hot, and at this point you can see the sediments accumulated down in this natural areas, that's probably a year or two later, and that pipe is bowed. So it didn't have a major impact on the flow, but it did at the very low volume of the pond. Then also we redesigned the Marley float skimmers in 2020. We replaced the one in this basin in 2021 with our newest model. Just wanted to use it kind of as a test for post-construction for using it in a permanent. And it did still have some issues with clogging. It's just like, again, it's a heavy debris area. So they were having to go down there and maintain it. Not hard to do, but we're having to do. So we added a debris guard around the skimmer. It just to help reduce the clogging. So this is just basically a polypropylene screen, mirror fiber fabric. It's got its own flotation in it. That just kind of helps keep the debris away from the skimmer to provide an extra layer of maintenance, relatively inexpensive and saves them a lot of time on having to check it. April 2023, the basin had accumulated about 3 feet of sediment buildup over the previous 9 years. That's what basins are supposed to do, right? That's how we provide water quality. We trap the sediment in the basin. So you can see here, had a contractor come in, you can see the traco here in the top right, dug out the area around the basin to provide more sediment storage, reinstalled the skimmer and the debris guard, and it continues to work today very well. So again, just a quick overview, mainly highlighting the maintenance benefits of skimmers. Didn't really touch on the water quality benefits. Having the skimmer withdraw from the surface versus the bottom of the pond. Talked about that a little bit at the beginning, but the main focus here is just, hey, skimmers are great substitutes for low flow water quality outlets for maintenance. Much easier to maintain, much less prone to clog, not having to get a lot of equipment in there to do. But obviously, and it's a good thing, but just what pond swimmers do trap a lot of sediment in the basins and will require cleanup eventually. Again, this is a heavy natural area, a lot of organic debris as well as sediment accumulating here. And so maybe even a little sooner than most for this area, but 3 feet of sediment in that area over 9 years is, could easily be expected. So that's it. Thank you for watching our skimmers for permanent use case study. Again, this is one of a series of videos. If you'd like to watch the entire series and get a continuing education credit for that, please do so. Email us at info@rymarwaterworks.com. Let us know which ones you watch. We'll send you a little simple quiz and be glad to get you a PDH certificate. Thank you.